Welcome to Homework Help on 2.7. We're doing solving quadratic equations with your choice. That's the big one there. This is more challenging than the previous lessons because now you have to decide which factoring method works. We're going to be doing these three problems from the homework. So first and foremost, let's get our notes down. I'll call this our toolbox because all of our factoring methods are right here, and this should be the method that you use to decide which method to use. Every time we have a problem to solve a quadratic equation, remember quadratic means it has an x squared in it. Anytime we're solving a quadratic equation, we'll always do these steps first. Number one, we need to set up properly. That means bring all the terms to the same side of the equal sign and set it equal to 0. This is so important. Check that first. Next, still part of our setup, we're going to pull out the greatest common factor. And if there's a negative in the leading term, we're going to factor that out also. After we've set up, we start factoring. Now, careful. We want to decide which method. If there's 3 terms, we'll use magic x, or at least we'll give it a shot. We'll try it. Remember, magic x, you need 2 numbers that multiply to a times c, and then that add up, a for add, to b. So they multiply up top and they add at the bottom. If we have 2 terms, we'll consider difference of squares, or we'll just isolate x. And I'll show you an example like that in a second. That'll be what we use for 2c. And then once we've factored, we'll set each factor equal to 0 using the zero product property. And that'll be our final step. Now, worst comes to worst, if none of these factoring methods work, we will instead use the quadratic formula. This guy always works, but because he's kind of complicated, it's best if we used him as a last resort. You've got to plug in for b squared minus 4ac all over 2a. There's a lot of simplification here. So you want to leave that as a last resort if possible. All right, let's do the first problem. Number 1a. So the problem says x squared equals 9x. Now have a look back at our notes. By the way, if you need to pause the video and take these notes down, that would be a great idea. We're always going to refer back to our notes. So step 1, it says bring all terms to the same side of the equal sign. Now, right now, that's not the case. So we need to bring everything to the same side. Let's minus 9x minus 9x. I'm going to be left with x squared minus 9x equal to 0. Okay, so first part of my setup is complete. Next, I want to pull out any greatest common factor. So I'm going to, no matter what kind of situation I have, see if there's anything I can factor out, anything that's common between x squared and 9x here. And indeed there is. I can pull out an x. If I factor out an x times what is going to give me this x squared? Well, that's x. And I'm left with a minus 9 also. So we can just FOIL this, or distribute it back in to make sure. X times x gives me the x squared, and x times negative 9 gives me the negative 9x that I needed. So that does work. Okay, we factored out our greatest common factor successfully. Once we're done, I'm ready to set each factor equal to 0 because I'm already in factored form. I'm in factored form. Remember, factors are just pieces that multiply. So once I've got it looking like this, in parentheses, technically there's parentheses right there, then I'm ready to set each factor equal to 0. So we're going to do that here. I get x equals 0, and I get x minus 9 equal to 0. Well, this guy is nice and solved already for me. X equals 0 is one of my solutions. Here I've got to do a little work. I need to find out what x is, so I'm adding 9 to both sides. I get x equals 9. So indeed, we have 2 solutions here, x equals 0 and x equals 9. Both of them satisfy this equation. So just a quick recap. Here, we had to set up by moving our factors to the same side of the equal sign and setting them equal to 0. Our second step was to factor out the greatest common factor, which was an x. And we're done. Let's do the next problem. Number 2c. Okay, notice that in this problem, unlike the previous one, there's only an x squared. There's no x term. So since in this case it's actually possible to get x all by itself, that's what we're going to do here. I want to solve for x, and since there's only an x squared, there's not a second x lingering about. For instance, there's no extra 2x there. I can just go ahead and divide both sides by negative 25. I'm going to start isolating x. If I divide both sides by negative 25, I'm left with x squared equals, that's really negative 81 over 25. Okay, I still need to get x by itself. Right now I have x squared. So in order to undo this power of 2, I need to take the square root on both sides. Taking the square root undoes my power of 2. So I'm left with x equals. Now, we can simplify this piece here. I'm going to rewrite it like this. And this is how we simplify radicals when we're applying it to a fraction. You really take the square root of the top and the square root of the bottom separately. Now, square root of negative 81, careful, this negative inside here means I've got an imaginary number. So immediately I'll write I. And then the 81, well, that's a perfect square. That's 9. Same with my denominator. Square root of 25 is 5. So I'm going to write 9i over 5. But wait, see if you remember that when you take the square roots on both sides of the equal sign, you must include a plus or minus. There are really 2 answers here. And so we're done. X equals plus or minus 9i over 5. You can do the same process for 2a and 2b also, isolating your x. Let's do the last problem. I have r squared plus 9 equals 2r. Okay, now this is different from both of the previous problems because I've got 3 terms, but we'll always start the same exact way. I'm going to get all my terms to the same side. So let's minus the 2r here, minus the 2r here, and I want this guy to be positioned in the middle. So I'm going from r squared to r to my constant. So I'm going to rewrite it, r squared minus 2r plus 9 equal to 0. Okay, I have 3 terms. See if you remember from our notes. When we have 3 terms, we will try to use magic x. So let's go down and apply it. Okay, to use magic x here, I'm going to need 2 numbers that multiply to this guy times this guy, to a times c. So I need 2 numbers that multiply to 1 times 9 is 9, and that add up to the middle number, b, and that's just negative 2. So numbers that multiply to 9, let's start there, are 1 and 9, 3 and 3, and that's it. Now, neither of these, if you think about it, will ever combine to add up to negative 2. This might add up to negative 8 or positive 8. This is going to add or subtract to 0 or 6. It's not really getting us anywhere. But we tried magic x just like we're supposed to. Unfortunately, this does not factor. It doesn't factor. We tried. Didn't work. So when we hit a wall like this, our go-to method, our final resort, is our quadratic formula. This is the time to bust out that formula. Remember, it's x equals, and it's always a good idea to rewrite it. Negative b plus or minus square root b squared minus 4ac all over 2a. Okay, let's very carefully plug in. I'm going to rewrite the problem so it's a little neater. we had r squared minus 2r plus 9 equal to 0. Okay, we're going to use the quadratic formula here. Let's first identify, we're plugging in for b, for a, and c. Let's at least identify what those coefficients are. So a is the number in front of my x squared, or my r squared in this case. That number is a 1 here. My b is negative 2. That's my a, that's my b. And my c is going to be this positive 9. So we're going to plug in. X equals. Now keep in mind, this part, when you use the quadratic formula, it's really just testing. Can you plug in carefully without making silly mistakes? Got to do our best. X equals negative, now my b. So that's negative 2. Okay, that's negative b, plus or minus the square root of b, which is negative 2 again. I put it in parentheses always. B squared minus 4 times a, which is 1, times c. So this is a, this is c, which is 9. And don't forget, it's all over 2 times a. Okay, let's simplify. Negative 2 is positive 2, plus or minus negative 2 squared, or negative 2 times itself, is 4, minus 4 times 1 is 4 times 9 is 36. So this guy became 36, and it's a minus 36 all over 2. Let's keep going. X equals, now we need to simplify this part. Make a note. Keep going until it's all simplified down. So I've got 2 plus or minus 4 minus 36 is negative 32 all over 2. And we got to simplify that yet again. Simplify again. So however you break down square roots, you're going to use that method. It might be a factor tree. I use this method with my class. 2. So we're always pulling out the doubles. So do it your way, but check if you would have got 4 square root 2. But wait, there's a negative inside. That means I've got an imaginary number. All over 2. So in case you just got lost in that step from here to here, I just simplified this. You can use a factor tree or whatever method you use, and you should get 4i square root 2. All right, we're almost done. We're not allowed to leave it like this. We're going to simplify our fraction by breaking up the fraction in the last step. So I've got x equals 2 over 2 plus or minus 4i root 2 over 2. Now keep in mind, this plus or minus just means I've got 2 different possible answers. I'm going to do both. My first one is, well, that's really 1 plus 4i root 2 over 2. And this second answer is x equals 1 minus 4i square root 2 over 2. Okay, let's finish this out. This simplifies, becomes a 2, that becomes a 1. Same here. And so my 2 answers are 1 plus 2y root 2, and x equals 1 minus 2y root 2. We got 2 imaginary solutions in this case. So quick recap. For this problem, we noticed we had a trinomial. Let me direct your attention here. We knew we had a trinomial, so we tried magic x. It doesn't always work, and in this case it didn't. So we had to use the quadratic formula as our last resort. Very, very carefully simplifying, we ended up with 2 answers. 1 plus 2i root 2 and 1 minus 2i root 2. All right, that was our lesson. Good luck with the rest of your work.